I simply want to make ever better car, no matter what kind of the powertrain
There's
they
times
have.
when there are rocky moments, like things are it's like a little bit of stormy weather.
Something massive just shook the auto industry. Toyota has been quietly developing a revolutionary engine that could make Tesla's entire business model irrelevant. No long charging times, no rare earth metal shortages, just clean energy with instant refueling. And here's the real shocker. This might be the biggest leap forward in automotive history. So, is this a true industry game changer or just another overhyped breakthrough? Let's find out. What's happening? Toyota has just unveiled a groundbreaking engine that could change everything. Unlike conventional gasoline engines, this new innovation is designed to run on hydrogen and synthetic fuels, delivering near zero emissions without sacrificing the power and range that internal combustion fans swear by. The announcement sent shockwaves through the industry. For years, Tesla has positioned itself as the undisputed leader of the electric revolution. But Toyota's latest breakthrough proves that the future may not belong to EVs alone. And this is where the real battle begins. Toyota is not just launching another hybrid. They are directly challenging the idea that EVs are the only way forward. If this engine is as efficient, clean, and cost-effective as Toyota claims, it could shake the foundation of Tesla's entire business model. With this move, Toyota has drawn a line in the sand, and Tesla may never be the same again. Let me explain why Toyota's plan is a direct attack on Tesla. Tesla has spent nearly 2 decades convincing the world that electric vehicles are the only viable path forward. Musk's entire business model is built around a future where internal combustion engines become extinct, replaced by fleets of battery-powered cars charging at Tesla's ever-expanding supercharger network. But Toyota? They never bought into the idea that electric was the only answer, and now we know why. While other automakers scrambled to develop fully electric lineups, Toyota continued investing heavily in alternative fuel sources, hybrids, and hydrogen power. Many questioned this decision, accusing the company of being stuck in the past. But Toyota had a long-term strategy that is now becoming clearer. The company understood something that others ignored. EVs come with massive challenges that have yet to be solved. The biggest hurdle for EV adoption is not technology, it is infrastructure. Charging networks remain inconsistent, and long charging times continue to frustrate consumers. Despite government incentives and aggressive EV mandates, many drivers are still hesitant to switch due to concerns about range and accessibility. Toyota's new engine bypasses this problem entirely. With hydrogen and synthetic fuel capability, it offers the same convenience of traditional gasoline-powered cars, quick refueling, no need for charging stations, and greater long-term reliability. Another critical weakness of EVs is the dependence on rare earth metals. Tesla and other EV manufacturers rely heavily on lithium, cobalt, and nickel, minerals that are not only environmentally damaging to mine, but are also controlled by a small number of suppliers, many of whom are in politically unstable regions. Toyota's new engine, on the other hand, avoids this issue completely. If successful, it could remove the need for lithium-ion batteries altogether, dealing a massive blow to the EV battery industry. Toyota has been playing the long game while Tesla has been racing toward full electrification. Now, with a functional, scalable alternative to battery-powered EVs, Toyota is positioning itself to undermine Tesla's entire business model. The world was told that electric vehicles were the only way forward, but Toyota just proved that narrative wrong. But what exactly is this engine? And why does Musk think it could destroy the entire EV industry? Toyota's game-changing engine. This new engine is not just an improvement, it is a complete reinvention of how cars can be powered. Unlike traditional engines, Toyota's latest innovation runs on a combination of hydrogen and synthetic fuels. Hydrogen combustion is nothing new, but Toyota has managed to overcome the biggest challenges that have held it back in the past. By refining the combustion process and emissions control, they have created a system that offers near zero carbon output while maintaining the power and efficiency of a conventional gasoline engine. This means that drivers can experience the instant refueling and long-range benefits of gasoline-powered vehicles, all while producing emissions that are as clean as, or cleaner than, EVs. One of the most surprising aspects of this new engine is how it outperforms electric vehicles in key areas. EVs, while efficient, are limited by battery technology. Long charging times, energy degradation over time, and reliance on limited raw materials. Toyota's new engine completely avoids these pitfalls. Hydrogen refueling takes less than 5 minutes, meaning no more waiting for a charge. Additionally, synthetic fuels can be produced using renewable energy sources, making them a sustainable alternative to fossil fuels. Another major advantage is cost and scalability. EV battery production is expensive and places enormous strain on global supply chains. Lithium prices fluctuate unpredictably, and as demand rises, so do the challenges in securing materials. Toyota's hydrogen synthetic engine, on the other hand, relies on widely available resources, making it cheaper and easier to produce at scale. And while many assume that Tesla is too big to be affected, history tells us otherwise. Automakers that fail to adapt to industry shifts do not survive. Toyota's breakthrough engine is not just another hybrid or a temporary fix. It is a direct challenge to Tesla's vision of the future. And the worst part for Musk? It is coming sooner than anyone expected. If you think this is just another experimental project, wait until you hear what Toyota has already patented. EVs are slowing down. Toyota saw it. Coming for years, electric vehicles were marketed as the inevitable future of transportation. Governments, automakers, and environmental advocates all pushed the narrative that gasoline-powered cars were on the way out, and that an all-electric world was just around the corner. But now, in 2024, something unexpected is happening. EV sales are slowing down, and automakers are starting to rethink their strategies. In the United States, electric vehicle sales grew by only 18% in 2024, a steep decline from the 50% growth rate seen in previous years. In China, the world's largest EV market, companies like BYD and NIO are struggling with slowing demand despite aggressive government subsidies. Even in Europe, where electric vehicles were once seen as the undisputed future, some manufacturers are hitting sales plateaus as customers hesitate to switch from gasoline and hybrid models. One of the biggest barriers to mass EV adoption remains charging infrastructure. While Tesla has built a massive supercharger network, the majority of public charging stations are unreliable, slow, and inconveniently located. In many cities, there are simply not enough fast chargers to support a full transition to EVs. And for apartment dwellers and those without home charging access, owning an EV is still a logistical nightmare. Another major roadblock is the cost and availability of lithium-ion batteries. Tesla, Ford, and General Motors all rely on lithium, cobalt, and nickel to manufacture their batteries. However, lithium prices have skyrocketed, and mining operations struggle to keep up with global demand. The environmental concerns surrounding lithium extraction and battery disposal have also raised questions about how green EVs truly are. Toyota saw all of this coming. While competitors rushed into an all-electric future, Toyota took a more cautious approach, investing heavily in hybrid technology and alternative fuels rather than relying entirely on battery electric vehicles. Now, as automakers begin to rethink their electrification strategies, Toyota's decision to hedge its bets is looking smarter than ever. But Tesla is not going to let Toyota win without a fight. Elon Musk's response, Tesla's secret backup plan. Elon Musk has always been bold and confident when talking about Tesla's future, but when asked about Toyota's new hydrogen hybrid engine, his response was surprisingly measured. Instead of dismissing Toyota's technology outright, Musk simply said, "I respect Toyota. They have some smart engineers over there, but we believe in our vision." This was a rare moment of restraint from Musk, who is usually quick to mock rival automakers. His reluctance to attack Toyota's engine outright suggests that he knows it could be a real threat to Tesla's dominance. Behind the scenes, Tesla has been working on its own alternatives to pure battery electric vehicles. Musk has hinted at a next-generation hybrid system, a solid-state battery breakthrough, and even hydrogen fuel cell technology, despite previously criticizing hydrogen as fool cells. In Tesla's 2024 investor call, insiders suggested that the company is reassessing its strategy and looking for ways to reduce dependency on lithium-ion batteries. One of the biggest concerns for Tesla is scalability. With rising material costs and battery shortages, producing millions of EVs annually is becoming increasingly difficult. Tesla's long-term survival depends on its ability to adapt, and Musk may be forced to rethink his all-electric vision if Toyota's new engine proves to be as disruptive as expected. However, Tesla still has an advantage: its supercharger network, which remains the gold standard in EV charging infrastructure. If Tesla licenses its supercharger technology to other automakers, it could create a new revenue stream while ensuring that its charging network remains the most reliable. Musk is not backing down, but the fact that Tesla is even considering alternative technologies is a sign that the battle for the future of transportation is far from settled. But this is not just a Tesla versus Toyota battle. Other automakers are also taking sides. Automakers are picking sides. The industry is divided. The automotive industry is now split between those doubling down on EVs and those looking for alternatives. Toyota's move has forced other automakers to make a choice: stick with battery electric vehicles or explore hybrid, hydrogen, and synthetic fuel options. Ford, once fully committed to EVs, is now scaling back its electric vehicle investments and reinvesting in hybrid technology. The company has struggled with profitability issues in its EV division, and CEO Jim Farley has publicly stated that the transition to electric vehicles is happening slower than expected. In response, Ford is expanding its hybrid lineup, with new plug-in hybrid models expected by 2025. General Motors, which once promised to go fully electric by 2035, is quietly reconsidering that timeline. In recent months, GM executives have signaled support for hybrid models, admitting that EV adoption is not moving as fast as they anticipated. Meanwhile, European automakers like Volkswagen and BMW are investing heavily in synthetic fuels, and alternative engines. Volkswagen recently announced a partnership with Porsche and Siemens Energy to develop carbon-neutral e-fuels that could allow internal combustion engines to operate with near-zero emissions. BMW, on the other hand, is working on a new generation of hydrogen fuel cell vehicles, which could serve as a backup plan if EV adoption slows further. The key question now is, will Toyota's engine prove to be a true EV killer, or is this just another hype cycle? If Toyota succeeds, it could completely reshape the automotive industry. But if the technology fails to scale, the company risks falling behind in the race for electrification. And if history tells us anything, this is not the first time Toyota has changed the game. How Toyota dominated the hybrid market. At the turn of the 21st century, the idea of a hybrid car sounded like a science experiment rather than a practical vehicle for everyday drivers. The concept was simple: combine an internal combustion engine with an electric motor to improve fuel efficiency and reduce emissions. But at the time, gas prices were still relatively low, and automakers saw little reason to move away from traditional gasoline-powered vehicles. Most of the industry laughed at hybrids, dismissing them as a niche product that would never replace conventional cars. But Toyota saw something different. While other companies were betting on bigger, more powerful gasoline engines, Toyota was looking toward the future, where efficiency, fuel economy, and sustainability would define the industry. In 1997, Toyota introduced the Prius, the world's first mass-produced hybrid car. At first, it was seen as a quirky experiment, but Toyota continued refining the technology. By the early 2000s, as fuel prices spiked and environmental concerns grew, the Prius went from an industry joke to a global sensation. As sales of the Prius skyrocketed, other automakers scrambled to catch up. Companies that had once mocked hybrid technology rushed to develop their own hybrid models, but they were years behind Toyota. Honda released its Insight Hybrid around the same time as the Prius, but it never gained the same level of popularity. General Motors, Ford, and Nissan were forced to rethink their entire strategy, introducing hybrid versions of their most popular models just to stay competitive. What made Toyota so successful was not just the hybrid technology itself, but how they perfected it. The Toyota hybrid system was designed to seamlessly switch between electric and gasoline power, optimizing efficiency without sacrificing performance. By continuously improving battery technology and refining regenerative braking systems, Toyota managed to offer hybrids that were more reliable, fuel-efficient, and affordable than anything else on the market. The biggest proof of Toyota's success? Over 15 million Toyota hybrids have been sold worldwide, making it the most dominant hybrid brand in the world. Other automakers have tried and failed to challenge Toyota's hybrid leadership, but the company's decades of experience and commitment to refinement have kept it ahead of the game. And now, Toyota is using that same strategy to take down the EV industry. The company is once again being dismissed by critics for not going all in on electric vehicles. But just like they did with hybrids, Toyota is betting that the future is more complicated than a single technology. And this time, they are developing an engine that could completely change the automotive landscape once again. Toyota's hybrid success proves they know how to see the future before the rest of the industry. And now, their latest patents reveal a bold new plan that could reshape everything we know about car engines. What Toyota's patents reveal about their future plans. When a company starts filing patents in secret, it usually means they are working on something big. Toyota has been filing patents at an accelerated pace, and what they reveal is nothing short of revolutionary. These patents don't just focus on traditional hybrids, they suggest that Toyota is developing a new type of engine that could make electric vehicles obsolete. One of the biggest breakthroughs hidden in Toyota's patents is a hybrid hydrogen engine that combines the efficiency of an electric motor with the power and convenience of an internal combustion engine. Unlike traditional hybrids that rely on gasoline, Toyota's new system is designed to run on hydrogen and synthetic fuels, meaning it produces near-zero emissions without the need for massive lithium-ion batteries. But Toyota is not just thinking about passenger cars. Their patents indicate they are looking to expand this technology across multiple vehicle segments, including trucks, SUVs, and even heavy-duty commercial vehicles. This is critical because while EVs might work well for smaller passenger cars, they struggle with larger vehicles that require more power and range. By using hydrogen combustion and hybrid integration, Toyota could create fuel-efficient trucks and SUVs that outperform electric alternatives without range anxiety or long charging times. The most shocking part? Toyota is not waiting decades to roll this out. Insiders suggest that these new engines could be ready for production as early as 2027, meaning they are far closer to mass adoption than most people realize. Toyota has already proven they can change the industry with new technology. They did it with hybrids, and now they are preparing to do it again. But are they really the first to try this? The truth is, other automakers have experimented with hydrogen engines before, but failed. The Honda Hydrogen Experiment. For decades, Honda has been known for its engineering excellence, fuel efficiency, and reliability. But in the early 2000s, the company set its sights on a new goal: leading the hydrogen revolution. Honda wanted to create a car that could offer the clean energy benefits of an electric vehicle, but with the refueling convenience of a gasoline car. That was the idea behind the Honda Clarity fuel cell. At first glance, the Clarity seemed like a technological marvel. It used a hydrogen fuel cell to generate electricity, which then powered an electric motor. Unlike battery-powered EVs, the Clarity did not need hours to recharge. It could refuel in just 3 to 5 minutes, just like a traditional gas car. Even better, it produced zero emissions, with only water vapor coming out of the tailpipe. Honda believed it had found the perfect balance between sustainability and convenience. But the dream quickly ran into reality. The biggest problem? Infrastructure. Unlike gasoline stations, which are available everywhere, hydrogen fueling stations were extremely rare. In fact, even at the peak of its rollout, there were fewer than 100 hydrogen stations in the entire United States, and almost all of them were concentrated in California. This meant that unless you lived near one of those stations, owning a Clarity was completely impractical. Another issue was cost. Hydrogen production and distribution were far more expensive than gasoline or electricity. While EV charging infrastructure was expanding rapidly, hydrogen stations remained stagnant, making it difficult for mainstream adoption. On top of that, fuel cell technology itself was still very expensive, which meant the Clarity had a high price tag with no significant cost savings over traditional EVs or hybrids. The result? Total market failure. The Honda Clarity fuel cell never saw widespread adoption, and Honda was forced to discontinue the model in 2021. The company quietly phased out its hydrogen vehicle program, shifting focus back to hybrids and battery EVs. But while Honda's hydrogen push ended in failure, Toyota was watching and learning. Toyota understood that the technology itself was not the problem. Instead, the lack of infrastructure and high production costs were the biggest barriers. Now Toyota is taking a different approach, one that could finally make hydrogen a real alternative to electric cars. And Honda was not the only company to struggle with hydrogen. BMW tried too. BMW's forgotten hydrogen cars. While Honda's attempt at a hydrogen-powered vehicle was short-lived, BMW had been experimenting with hydrogen technology for decades. As early as the 1980s, BMW engineers were testing hydrogen-powered internal combustion engines, believing that hydrogen could be a cleaner alternative to gasoline. The company's most serious attempt came in 2006, when BMW unveiled the Hydrogen 7, a modified version of its 7 Series luxury sedan. Unlike Honda's Clarity, which used a fuel cell, the Hydrogen 7 burned liquid hydrogen directly in an internal combustion engine. BMW marketed it as the best of both worlds, a traditional engine that could run on either gasoline or hydrogen, giving drivers the flexibility they needed. But despite the hype, the Hydrogen 7 never went into mass production. The biggest reason? Storage and efficiency problems. Liquid hydrogen must be stored at extremely low temperatures, which made refueling stations even more expensive to build than Honda's fuel cell system. Even worse, the Hydrogen 7 had serious efficiency issues. It burned through hydrogen so quickly that its range was shorter than most gasoline cars. Ultimately, BMW quietly ended its hydrogen combustion program, shifting focus toward battery EVs instead. The failure of the Hydrogen 7 proved that burning hydrogen in a traditional engine was not the answer. But Toyota's approach is fundamentally different. Instead of relying on outdated combustion methods, they are blending hydrogen with hybrid technology, making their system far more efficient. But the biggest failure in hydrogen history wasn't from Honda or BMW, it was from General Motors. General Motors and the hydrogen hype that went nowhere. In the early 2000s, General Motors was one of the biggest advocates for hydrogen fuel cell vehicles. The company poured billions of dollars into research, claiming that hydrogen cars would soon replace gasoline vehicles entirely. GM even developed the Hydrogen series, a fleet of experimental vehicles designed to showcase fuel cell technology. For a while, it seemed like hydrogen could be the future. GM received government backing, and hydrogen fuel cells were promoted as the next major breakthrough in clean energy. But as the years went on, a huge problem emerged. Hydrogen fuel cell vehicles simply could not compete with battery-powered EVs. Unlike Toyota, which was refining its hybrid hydrogen engine for mass production, GM focused on pure hydrogen fuel cell vehicles, which required an entirely new fueling infrastructure. Meanwhile, Tesla and other automakers were expanding EV charging networks, making battery-powered cars far more convenient for consumers. By 2014, General Motors abandoned most of its hydrogen fuel cell programs. The company realized that battery EVs were scaling much faster, while hydrogen still had major barriers to adoption. GM's hydrogen research continued in commercial trucking, but for passenger vehicles, the company fully committed to EVs instead. Toyota, however, is not making the same mistakes. Unlike Honda, BMW, and GM, Toyota is not relying solely on hydrogen fuel cells. Instead, it is developing an engine that blends hydrogen with hybrid technology, meaning it can work alongside existing fuel and hybrid systems. This reduces infrastructure problems, improves efficiency, and makes the transition to hydrogen much easier. So, what makes Toyota different? And can they actually pull this off? Will Toyota's engine really kill EVs? The rise of electric vehicles seemed inevitable, but Toyota's hybrid hydrogen engine could change everything. The real question is, will Toyota's innovation disrupt the EV industry, or is it just another overhyped experiment? There are three possible futures that could unfold as this battle plays out. The first scenario is that EVs continue to dominate, and Toyota's hydrogen engine remains a niche alternative. This would happen if battery technology advances faster than expected, making electric vehicles more affordable, charging times shorter, and infrastructure more widely available. Governments are still heavily investing in EV adoption, and Tesla is leading in software development, battery efficiency, and autonomous driving. If these trends continue, hydrogen engines may never gain widespread traction. The second possibility is that hybrid hydrogen engines become the new standard, overtaking battery EVs in key markets. If Toyota successfully proves that hydrogen-powered internal combustion can match or exceed the efficiency of electric vehicles, it could create a new industry standard. The ability to refuel in minutes, avoid reliance on lithium and rare earth metals, and eliminate battery degradation could make Toyota's engine an attractive alternative for consumers who do not want to deal with the limitations of EVs. The third and most likely outcome is a split market, where both EVs and hybrid hydrogen vehicles coexist. In this future, battery EVs dominate in urban environments, where charging stations are plentiful, and hydrogen-powered hybrids are preferred for long-distance travel. This would allow automakers to offer multiple solutions, rather than forcing consumers into a one-size-fits-all approach. It is possible that Toyota and Tesla could both succeed by focusing on different segments of the transportation industry. So, what do you think? Will Toyota's hydrogen breakthrough reshape the auto industry, or will Tesla's EV dominance continue? Let us know in the comments.